we want to look at series. And a series is a sum of a sequence. Series is a sum of a sequence. We can express a series in kind of smaller notation. So instead of writing 1 plus 2 plus 3 plus 4 all the way to 100, we can use this Greek letter for S. It's a capital letter for S called sigma. Ancient Greek did not have capital letters. If I were to spell the word sigma, it would look like this. And if you had sigmas, you would put the S at the end. If you end with an S at the end, it looks like that as opposed to like that at the beginning. These are the S's or sigmas that are used in, say, a study, say statistics. But this is the capital S, and it means sum. We add things up. And you see something on the bottom here, and that's how we generate the first term. And you see something at the top here, which is how we generate the last term. It is not actually the first term or the last term. It's how we generate it. And what tells us how we generate it is the rule that sits right over here. And so what we're going to do is we're simply going to take these summations. They're called summations because they have sigma, so it means sum. We add them up. We're going to simply write them in an expanded form. So I start with plug. In order to generate the first term, I plug in 2. 3 times 2 plus 1, 7. And then plus because I have a summation sign. After 2, I plug in 3. And 3 times 3 plus 1 is 10. I start by plugging in 2, and I will work until I plug in 5. I plug in 4. 3 times 4 is 12, plus 1 is 13. And finally, 3 times 5 is 15, plus 1 is 16. So as you can see here, I have 4 terms. That's the expansion, the summation. Nope, just leave it. It just says expand. That's the direction. I'm waiting. I apologize. A lot of times I is used and a lot of times N is used. I should have made them the same. Let's generate letter B. Letter B, it says I start with 1, so I plug in 1, and I go up until 3. So if you plug in 1, what is 4 to the 0? Times 2, plus, I plug in 2. 2 minus 1, 4 to the 1, times 2, plus 3. So 3 minus 1, and 4 squared, times 2. Very good. Okay. So C, we're going to plug in 1, and 2 minus 5 is, and then 2 minus 10, and 2 minus 15. And then instead of going all the way out, through 100 terms, we can write dot, 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 and we just put the last term at the end. So if we plug in 100, you get 2 minus 500, which is, so we can see the summation here that you get. So, you write at least 3 dots, you're good to go is kind of generally the accepted idea. So we'll skip D. So what we like to do is we like to take a finite group. So that's not infinite. There's a set number of terms. And we like to be able to add them up. Let's think about what Gauss did. What Gauss did is he said if you want to add up the first number of terms, what did he do to add up the numbers 1 through 100? He took the first plus the last. So that would be the a sub 1 term plus the a sub n term. So he got that, but what did he multiply it by? Yeah, how many pairs were there? Which was half of the total number of terms. So we're going to multiply by half of the number of terms. And that will generate for us the sum. So let's understand what we're doing for letter A. It says, find the sum of the following arithmetic series. We start with 1, and you plug 1 in, you get, plug in 2, and you get, plug in 3, and you get dot, 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 all the way up to, if you plug in 20, you get 61. Okay, so we're trying to add up that sum. We're trying to do it rather quickly. So we could take S sub 20, we like to know that sum of the first 20 terms is equal to, what does my formula say I do? 20 times 4 plus 61 divided by 2. So as you can see, 20 divided by 2 is, so there are 10 pairs, and each pair adds up to 65, so you get 650. So that's all that the formula is. You clear about what the formula is doing? Okay. Which part? That means if you took 4 plus 7 plus 10 all the way up to 61, you would get a result of 650. Good question. Please do letter B on your own. Did you get 1020? Very good. Flip it over. What is different about letter C? They're not given a rule. So we have the sum, and we don't know the number of terms. The sum of a certain number of terms is equal to the number of terms times -8 plus 58 divided by 2. So I got to figure out n. Would you agree that this is an arithmetic sequence? Why? So we have a constant difference. Yep. What's the constant difference, William? It is 3. And so we had this formula just the other day. A sub n is equal to a sub 1 plus your difference times n minus 1, right? Maybe we could use that to figure out n. Let's let a sub n be the last term and figure out what term number it is. What is our last term? So 58 is equal to the first term, -8, plus the difference, which is 3 times n minus 1. And so you get 66 is equal to 3 times n minus 1. Divide by 3, 22 is n minus 1, so n is 23. So S sub 23 is equal to 23 times 50 over 2. Or 23 times 25, which is 575. How about it? Little trick involved there, huh? See if you can do letter D on your own. I got 43,659. Is there any question from anybody how I came up with that? So I had 98 divided by 2, which was 49. Yes. Oh. No, it's fine. that question? Going once, twice, 3 times. So that's arithmetic. What if we have geometric? Well, the sum of the first n terms of a geometric series is equal to a sub 1 times 1 minus r to the nth divided by 1 minus r. Now, as you look at this, it's very important for you to recognize what are you asked to know in both the arithmetic series sum as well as the geometric series sum. A sub 1. What do you not have to find in the geometric series sum that you did have to find in the arithmetic one? A sub n, you don't need to know the last term. We don't need to know the last term. So it says find the sum of the following geometric series. If we expand this, if we plug in 1, we get 1 minus 1 is 0. Anything 0 power is plus. And then if we plug in 2, we get 1/2 to the first power, which is. And then if you plug in 3, you get 1/2 to the second power, which is. So everybody see how this is going? I'm not going to write down the last term because I don't need it. But I would like to sum this. This is the sum of how many terms do we have? 9 is equal to, what's the first term? So I don't need it, times 1 minus, what is r? What are you multiplying by every time? Does everybody understand that this is r right here? So yesterday we said a sub n is equal to a sub 1 times r to the n minus 1. So what's sitting in place of the r right here? 1/2. And if you look at the terms, can you convince yourself you're multiplying by 1/2 each time? Okay. All right. So I wrote that out to give you 2 ways to recognize that r is 1/2. You can either write it out and recognize it, or you can look at this spot and say it's 1/2. So I have 1 minus 1/2 raised to what power? 9 divided by 1 minus 1/2. Hey, what's 1 minus 1/2? So dividing by 1/2 is the same as, so I have 2 times 1 minus 1/2 to the 9th power. Okay, I'll write it out again. So we've got 1 minus 1/2 to the 9th divided by 1/2. Dividing by 1/2 is the same as multiplying by 2. Okay. All right. So I'm going to figure it out with my calculator quick here. So I've got a handy-dandy calculator. I'm going to use it. I'm going to do 2 times parentheses 1 minus parentheses 1/2 raised to the 9th power. And I press enter and I get that. Now, as you look at these 1 plus 1/2 plus 1/4, just think about it for a second, folks, okay? What's 1 plus 1/2? 1/2 plus 1/4, 1 3/4. Then it would be plus 1/8, right? Be 1 7/8. And then plus 1/16 would be 1 15/16. So it looks like it's getting close to what number? Looks like it's getting close to 2, and sure enough, we're close to 2, aren't we? But it doesn't seem like it should, kind of work out to be a rational number. Well, if we just simply convert it to a fraction, you can see you get 511 over 256. Oh. For letter B, we plug in 1, and what do you get? 6. Very good. And then if you plug in 2, you get 6 times 2/3, which is 4. And so on and so forth, right? Okay. So we're going to do the sum of the first how many terms? 6 terms. That's going to be equal to, what is the first term? 6 times 1 minus, what is r? 2/3 raised to the 6th power divided by 1 minus 2/3. What is 1 minus 2/3? 1/3. What's 6 divided by 1/3? It is 18. So the sum of the first 6 terms is 18 times 1 minus 2/3 to the 6th power. So the rule says 1 minus r in the denominator. (18) 1 minus parentheses 2/3 raised to the 6th power. And I get that thing. And if I simply just convert it to a fraction, there's a good chance that it converts. In fact, I get 1330 over 81. Well, yes, but I don't think as you look at the original numbers, if you have rational expressions are being added together, they will add up to a rational number. So we'll take a different example. Suppose you get, say, 3 divided by 7. You're like, well, there's no way that that converts to a decimal. And but you try it, and you're like, oh, hey, it actually does convert to 3/7. If you take a different number that you're worried about, like you're getting fancy, and you're like, okay, well, I want to try to write pi as a rational number, and you hit that math button, convert to fraction. The calculator will actually explode, and oh, okay, well, I didn't. Okay, but as you can see, I didn't get anything special today. So, okay. Let's skip C. Let's do problem D. What's different about problem D? Yeah, so we have the sum of the first n terms. We don't know what n is equal to first term 3 times 1 minus, what's the ratio? 2 to the nth power divided by what? 1 minus 2. What's 1 minus 2? It's -1. So 3 divided by -1 is, so we have -3 times 1 minus 2 to the nth. So that's what it's going to sum to, but we've got to figure out n, don't we? Shoot, how do I figure out n? Okay, this is a geometric, so instead of using our arithmetic rule, we're going to use our geometric rule from yesterday. Because 1 minus 2 was -1. Sorry, this was Monday. Yesterday I taught this in a different class, but for you guys it was Monday. So I have a sub n. What's my last term here? 384 is equal to the first term, 3 times r. What's r? 2 raised to the n minus 1. So I have that rule as a geometric sequence. So I want to solve for n. Anybody see how I could solve for n? Divide by 3. Who said that? Good job, Gigi. If I take 384 and I divide by 3, I get 128 is equal to 2 to the n minus 1 power. Now I need to get rid of a base of 2. Log base 2. Yeah, it is a class where we do expect you to be able to do the stuff that we did before. They don't like you. So you can see that those go away, and I'm left with n minus 1. How do I compute log base 2 of 128? Log of 128 divided by log of 2. 7. So therefore, what is n? So if n is 8, what do I do with that now? Plug it in right up here. So negative 3 times 1 minus 2 to the 8th. If you can point to me where you're lost, I will help direct you. Do you see how we got log base 2 of 128? I got 7. Yep. So then I type in negative 3 times 1 minus 2 to the 8th. And I get 765. Yes. No, Olivia, our life is better because of you, and we appreciate that. We appreciate that. Okay. So we flip over, okay? All right. You don't have to write this down, but I'm going to show you something that is truly beautiful and amazing. Are you ready for it? Okay, here we go. So I'm going to write the sum of an infinite geometric series. So for example, we'll start off with this. 1 plus a half plus a fourth plus an eighth plus a 16th plus dot, 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 dot. You guys told me earlier, we kind of looked at that, and you saw what's 1 plus a half? 1 and a half. Plus a fourth, 1 and 3/4. Plus an eighth, 1 and 7/8. Plus a 16th, 1 and 15 16. So it looks like it's headed towards what? It looks like it's headed towards 2. Let's look at how we come up with this. We say the sum is equal to, we start with our first term. Everybody agreed? And then after that, we do the first term, but multiplied by whatever r is. Right? So we took the first term 1, and we multiplied by half. Well, the second term would be a sub 1, and we got multiplied by r again, right? So that would be r squared. And then a sub 1 again times r to the third, all the way on down. Agreed? Okay, well, I'm going to just carefully do this. I've got a sub 1 plus, notice all of these have what do they share in common? They share a sub 1. Now, I know that this is the trick, but they also share what? R, okay? If I factor out R, what's left here? A sub 1 plus, what's left here? R. What's left here? And then what would be next? Be a sub 1 plus R, right? So this is the trick, and we'll see if you can see it. Not everybody can, but some people can see it. I have a sub 1 plus R times a sub 1 plus a sub 1r plus a sub 1r squared plus a sub 1r third. Isn't this thing that I have right here, isn't that the exact same as what I have sitting right here? And what is it equal to? It's equal to S. Isn't this thing right here the same as this thing right here? And so I can replace all that with just S. Watch. I'm going to gather the S's on both sides. Are you okay with that step? Guess what I'm going to do now? Factor out an S. What are you left with? 1 minus R. Now I want to solve for S. What do? So if you want to know the sum of an infinite geometric series, all you have to do is this. Just take a sub 1 and divide it by 1 minus R. So let's do our... Okay, hold on. So grasp your mind, Ross. This is the essence of calculus. We are learning to calculate the infinite. You're adding up an infinite number of terms, and yet the result is not infinity. Because if you look at this first term, Gigi, this is 1 plus a half plus a fourth plus an eighth. This is the sequence we were talking about, the series we were talking about. So would you agree, as you add this together, 1 plus a half, you said 1 and a half, plus a fourth is 1 and 3/4, plus an eighth is 1 and 7/8. That'll be 1 and 15/16. That'll be 1 and 31/32. You agree it's never going to get over 2? Well, let's be careful how we speak of trending towards 2. Just to be clear, if I have the number... If I have the numbers 1 and 2, be careful to tell me that the series sums to something right around there. Because I could give you a few more terms and get it to be there, couldn't I? And as soon as you mark this, you say, well, you could get closer than that. As soon as you say, well, you're never going to get to 2, tell me the number I get to, and I can tell you I can get to a number closer than that. So it is ridiculous to think about, but you can sum an infinite number of things. I will prepare an explanation for you on Friday. Okay. But I will show you this. The sum is equal to what's the first term? Divided by 1 minus what is r? It's a half. What's 1 minus a half? What's 1 divided by a half? Boom. That is just the answer. We're done. We can talk about more stuff. Okay, so this one, we've already expanded this one out. This was 6 plus 4 plus 8/3. We did this earlier, okay? We wrote that out. And that was our series. And so the sum is equal to, what's the first term? 6 divided by, what's 1 minus 2/3? What's 6 divided by a third? 18. So finding the sum of an infinite geometric series is rather nice. How about this one? What's the first term? 1 minus r. What is r? R is 1/3. What's 1 minus a third? What's 12 divided by 2/3? Multiplied by 3/2 gives you, yep, very good, 18. And the last one, s is equal to, what's the first term? 3 divided by, what's 1 minus 2? So you get, very good. This is always one of my most disappointing moments throughout the year. Everybody puts their stuff away and they don't look at what's on the board. Look at what's on the board, you guys. You're adding these together and you get -3? Really? Come on, folks. 3 plus 6 plus 12. What's going to be the next one? 24. Right? What? Are you honestly going to get -3? No. Look at this. What do you get? You're going to go to infinity, aren't you? Yeah, you're going to go to infinity. So here's the deal. There's a caveat to this rule. If the absolute value of r is less than 1. If you notice, all your other ratios, you had a half, you had 2/3, you had 1/3. If r is less than 1, then it does what we call converges to a sum. It gives us a nice result, a nice answer. But if the absolute value of r is greater than or equal to 1, then it does what we call diverges to either infinity or negative infinity. And how do you know? Well, need to look at it. Or neither. Forgot about a different type of scenario. But you can see right here that it's obviously headed towards infinity. So because r was greater than 1, we ended up with a problem there. So you got to look at the sequence. 3 plus 6 plus 12 plus 24 plus 48. Here is your assignment. Yes. Yeah, it's 3, 6, 12. Well, that would be arithmetic. We would be using a different series sum. Yes. Yes. Well, here's an example. Okay, suppose you had this. 1 minus 2 plus 4 minus 8 plus 16 minus 32. So here you see that r happens to be -2, and it doesn't look like it's going to, like all of a sudden it's -1, but then it's +3, then it's -5, then it's +11. So like the positive numbers are getting bigger, but so are the negative numbers, depending on which term we get. So it's going to continue to just bounce back and forth, and it doesn't go anywhere. We would say that this oscillates. It just you can end up with some situations like that, but unfortunately not in this scenario. I could produce a different one that would kind of hone in. Ask a